Section 3.1 also looks at observations and experiments within the statistical process. Example 4 doesn't actually have a question to it, but it's a situation I want us to kind of look at and think about. Suppose a middle school finds that their students are not scoring well on the state's standardized math test. They decide to run an experiment to see if a new curriculum would improve scores. To run the test, they hire a math specialist to come in and teach a class using the new curriculum. To their delight, they see an improvement in test scores. With this particular experiment, you might notice that the school, in their efforts to improve their students' test scores, decided to not only purchase a new curriculum, but they also hired a math specialist. So the question is the improvement because of the new curriculum or the new math specialist? In this case, hiring a new math specialist creates a confounding variable. If they really wanted to look at whether or not the new curriculum in itself was the cause for improving test scores, they would want to make sure that they isolate the treatment, in this case, the new curriculum, so that there was no other potential source of a confounding variable. Example 5. In a study about an antidepressant medication, you have a psychologist evaluate each participant. Should this be a blind study or a double-blind study? I do want to note that in this study, the psychologist that you are hiring to evaluate each participant is not the person conducting the study itself. It might be wise to use a double-blind study. A double-blind study would allow you to eliminate any potential biases that the psychologist might have. This is helpful because we don't want the psychologist to introduce any of those potential biases to our study.